Corporate finance practice problem using OneNote. Cumulative voting problem number 2. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the Practice Problems tab down in the 1714 Cumulative Voting Problem number 2 tab. Also note, when using OneNote, look at the Immersive Reader tool. Our practice problems will be mirrored in the text area, same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top. We're going to go through the calculations on down below. Second problem of the cumulative voting problem. This one's going to be a little bit more complex, a little bit bigger of the numbers than our prior problem. So if you want a bit more simplified problem, take a look at the prior problem. Our question here, how many shares are needed to elect directors? 7 of 14. So in other words, cumulative voting, you'll recall, is going to be compared or contrasted to standard or a straight type of voting situation. In this situation, we're voting for a board of directors. So we are imagining ourselves to be the stockholders. We're the owners of the corporations in the form of stockholders. We're going to be voting for the board of directors. That's similar to kind of voting if you're a citizen in the U.S. or something, voting for, your congressperson or something like that, who is then supposed to act in your interest to hire the management. So in our case, the board of directors would then be hiring management. Management then, like the CEO and so forth, then conducting the operations of the organization. So we, owners, voting for then the board of directors to represent us. We're going to imagine 14 seats up for the election. You can see a similar type of situation in other kind of areas, such as a government area or a not-for-profit type of situation. Idea being here that the 14 seats, there's not really a hierarchy of the seats. That just got to be on the board, right? We're trying to get 14 people on the board. We can imagine then many people or candidates that could be electable, possibly more than 14, right? And then we're electing them. Now, if we had a straight type of vote, we would be voting basically for 14 of the seats, and everybody would vote for 14 of the seats, right? And if you had someone that was over the 51% of the power of voting, then they would win, all of them if there was a straight vote for each of the 14. However, if you use the cumulative voting system, it's typically thought that it could be beneficial for the minority votes in that, although we have the same kind of calculation of vote totals, meaning 14 seats times the number of shares, 120, you're not required to vote all of your votes in any particular seat, and therefore you can basically consolidate some of your votes, possibly giving more power to some minority interests in that way. So how many shares are needed? This is going to be a common question. The question being, in that type of cumulative voting situation, how many shares are needed to elect 7 directors, we're going to say, out of the 14. So we want to get 7 out of the 14 directors. How many shares do we need? The other question that could be asked is, if I have this many shares, how many directors could I basically guarantee to be able to pick up given the cumulative voting system, which we will do in a future problem. Now, we're going to say that outstanding shares are going to be 120,000 shares. The formula will be shares required are the number of directors needed times the total number of shares outstanding divided by the total number of directors to be elected plus 1. Now, if you're working this problem and expecting to see this in something like a test question, you might want to then write this down, do the algebra related to it for a few different times to practice that. We're going to break this into a format on a table type of format. Good practice for in practice, because using an Excel worksheet can help you to run different scenarios, often a good tool to use. So we're going to take the numerator and the denominator when we look at our table. Basically, I want to end up when constructing something like this with the numerator and denominator in the outer columns, and I'm going to pull inside any more complex type of calculations. So here we got the number of directors desired. That's going to be in our numerator. I'm going to pull that to the inside. We're going to say we want 7. We're looking to pick up 7 of the 14. 7 of the 14. Then we got the outstanding shares. The outstanding shares are 120,000 shares out there. So 7 times the 120,000, that would give us the 840,000. Now we're looking at the denominator, which would be the total number of directors to be elected, which is going to be 14. And then we'll simply add 1 to that. That will give us the denominator of 15. Now we're going to take the numerator divided by the denominator, the 840 divided by the 15 to give us the 56,000. Let's plug that into the calculator just for the fun of it. 840,000 divided by 15, 56,000 there. And then we're going to take that, we're going to add 1 to it. We're adding 1 to it. That's going to give us the 56,001. So question then, if this was a test question, we would say, okay, if there's going to be 14 people that are going to be up for election, we would need to have how many shares? 56,001 in order to guarantee that we pick up 7 out of those 14 seats for the board of directors. Now let's think that through intuitively, because many people will do this calculation and it means basically nothing. Really have no idea of what's actually happening here in terms of it. So it's useful to kind of try to think through, well, how does that work? So let's go through the thought process down below and let's just say, okay, if we had outstanding shares, total outstanding shares of 120,000, how many votes are out there? Well, we got 120,000 times the total number of directors to be elected, which is 14. That's how many votes that everybody has. That means that we have a total number of votes, 120 times 14, or 1,680,000. How many votes do we have as the minority interest? Now, notice I'm calling ourselves the minority interest here because that's often the terminology that will be used as to why the cumulative voting will be beneficial. But we're pretty significant here given the fact that we're looking for 7 out of the 14 seats. So you could think of it as basically us versus, us versus all other votes, right? That's how we're basically breaking this out. How many votes do we have in compared to everybody else? And then we're going to make the assumption that in the worst case scenario, how many votes could we pick up? What's the worst case scenario? The worst case scenario would be that the other person knows what our strategy is, and they're trying to block us. Not only the other person, but the other people, because the other people could represent a whole bunch of different people, right? It's not likely, possibly, that they all come together and then they know what we're going to do and act, try to block us. That may not likely be the situation, but what if it was, is kind of the idea here. So that what would we have to do to lock down the seats that we want, the 7 seats? Okay, so this is us. Then we're going to say, well, we just calculated the 56,001 shares, 56,001, and then we have 14 seats. So that means that we have 56,001 times 14, or 784,014 that we have to vote. These are how many votes that we can cast. We're going to try to concentrate them on the 7 seats that we think that we're going to pick up. Now, if the majority here, this is everybody else. There's not just 2 people involved, of course. This is everybody else, but we're assuming, worst case scenario, that they're going to act against us, act as one to try to consolidate their votes against us. So that means that the number of shares still remaining, 120 minus the 56,001, gives us the 63,999. They have that times 14 seats, so they have 63,999 times 14, or 895,986 votes that they could use to try to block what we want to do, to try to stop us from giving our 7 people on the board. So what would that look like then? You might say, okay, if we had a situation where we had these 14 seats, if you clear this 14, we're going to do a vote here, and we're going to have as many candidates as you might have, right? Whoever clears the 14 seats, has the most votes that they're within the top 14, they're on the board. It doesn't really matter so much where they lie in that scenario. That's kind of the idea. So if we have candidates, which I just labeled alphabetically, A through P, we're imagining these are names of candidates, then we need people to clear this in terms of the top 14 people. Now, us as the minority, or we're assuming we're the minority voters here, we're going to say that we elected candidates A through G. These are the people that we want on there. So it's pretty obvious who we're voting for if we elected them, right? We got these people, that's who we're looking for. So the majority would have, would have some concept of what we're doing here, and might, be more likely to block us if they wanted to in that case. So that means that what we're going to do is we're just going to take the number of votes that we have, which of course is this, we decided on the 784,014 divided by 7, and then we'll just allocate our votes out at the 112,02 all the way out for our 7 candidates. That's going to add up to the 784,014. Now, the other people, everybody else, let's imagine they're trying to block us and they all get together, or possibly it's one person, but you can say multiple people trying to block us. They're going to say, well, we know who they elected here, and we don't want them on there possibly, right? That's what we imagine in our game theory situation. So they're going to elect their own people here. So let's imagine we have these rest of the people that are elected, and they got to get in the top 14. Well, what they can do is try to beat us. So if our people all have 112,002, they can try to say, okay, I know their strategy. What they're going to do is try to pick up that, the top 7. So we're going to try to beat it by 112,003 for each of our people. Now, note they could try to go for a tie, and that could be a scenario as well. But let's imagine first that they try to go for 112,003 for all of their people. They can do that from H down to N for the next 8 through 14 in the ranking, but we gave them that no matter what. They can do whatever they want and pick up those seats because we concentrated all of our shares, all of our votes up top to make sure that we guaranteed the top 7. So we basically gave up 8 through 14. We're not contesting those per se. In order to get one more out from us, they'd have to get this last one, O here, to outpace one of our top 7. And they can't really do that because if we added these up, right, we'd say, okay, how many votes do they have? They got 112,003 plus 112,003 plus 112,003 plus 112,003, 112,003 plus 112,003 plus 112,003. Yes, it would have been easier to do multiplication there, but minus the amount of votes that they have, which is this amount, the 895,986, that means that they have only 111,965 to vote for this last one, and they need that last one to kick us out up top. Now, you might say, well, what if they could try to get it even closer a little bit by making this 112,002 so that all their candidates tie our candidates. But I don't believe that would also, even if they did that, I don't think it would clear this number. And I believe that's one of the reasons you have this +1 kind of calculation up top. That would be an unusual situation if they tried to say, okay, we're just going to use the same number all the way down, and you have a 14-way tie, and then they try to get this last one over the top with the extra 1, 2, 3, 4, 5, 6, 7 votes, right? Those added 7 votes, if we had that, would be the 111,965 plus 7. It's still not over the top here, and I don't believe it would be over the top in the general case, because the formula took that into consideration, I believe, with regard to one reason you have this +1 calculation. But that would be so in any case. So that then, if we have the total, then if we added up the total, we're adding these up. We're going to assume that there were no votes from the majority on our candidates, the A through G, and then they voted all on their candidates down here. If we take these totals then, these total numbers, and then we sort them by highest to lowest, so we see who's in the top 14, it would look something like this. We just copied over A and then the total column, and then sort by the total column. Then we see that our people down here are in A through G, but they're way at the bottom. So G's way down here at the bottom. They're not at the top of the winners, but they all fall within, the top 14. It looked like they were outside, but they're in there. There's the 14. If you count them off, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So O didn't make it. They would need to have O in there to kick out one of these people up top. So this one would have had to be over the 112,002, you would think, to remove one of these people that we elected up top out of the bracket. So again, the idea here is there's no basically hierarchy. If you're on the board, you're on the board. If you won your seat on the board by a greater margin than somebody else, that doesn't give you any actual authority, any actual power over anybody else from a functional standpoint. It might from a political standpoint by saying that I have a mandate or something like that, but from a functional standpoint, it shouldn't, right? And so the idea is here we're doing what we can to kind of guarantee the most amount of seats on there, because obviously the voting power on the board is what's trying to be maximized at this point. So this same concept, again, you could put the same concept in like a government type of setting, or if they're doing a similar situation for some kind of elected government area or not for profit areas, if they're using this similar kind of concept where you're basically looking for a group of people like a board or something like that that have in essence equal power on it, and you're trying to vote in basically a certain number of group into that area, you might see a similar kind of cumulative voting type of structure.